Welcome back. This is section 7.2, rational exponents. For these next several examples, you need to really understand some of the exponent principles and properties that we've learned before in previous sections. So a quick recap, if we multiply terms that are raised to a power and they're the same base, so these are like bases, you add the exponents. If we have a negative exponent, you put it to the bottom, or you'd flip it. If it's in the bottom, you go to the top. If you divide exponents, the same thing as subtraction. Notice how these are like bases. If we have a fraction raised to the negative power, you flip the fraction. I showed an example last video on how you do that. And then you make the exponent positive. If we raise a power to a power, okay, this is the only time you multiply the exponents. Okay, if we have two terms inside, all raised to a power, you need to raise this power to everything inside that's being multiplied. Very similar to what we had before, we have a ratio here. It's the same thing as both of these terms being raised to the power. And then finally, if we have a to the negative r, it's the same thing if we put 1 over a and then raise that to the r power. Okay, we're going to apply those principles in these next few examples, and then you'll be good to go. So first up, we have 2 to the 1/2 times 2 to the 1/2. That's the same thing as the square root of 2 times the square root of 2. Please see the previous video on what that means for rational exponents if you're confused on that. But basically, if we have like bases, which they are, we add the exponents. So 1/2 plus 1/2 is 1, 2 to the first power, and that's what we should get either way we do that. There's our answer. Okay, now we have 5 to the 2/3 over 5 to the 7/3. Because these bases are like, we're just going to do this. We're going to do 2/3 and then minus the exponents over 7/3. Once we simplify this, we get 5 to the negative 5 over 3. I wouldn't leave it as a negative exponent unless it says it's okay, so let's simplify this further. We need to have it as 1 over 5 to the 5 over 3 power. Okay, that's very important that you write it like that. And if we wanted to put it in radical form, we could do 1 over the cube root of 5 to the 5th power. Okay, I'm going to leave it like that because we're going to get a decimal for an answer. Okay, next up we have everything in terms of variables. Nothing too bad there. Now we have a y. Keep in mind that anytime you have variables in the top and then we have nothing appearing that it's nothing in the bottom for exponents, we can have an imaginary 1 there. Okay, so what does that mean? Well, that means I need to subtract my exponents with the like bases. Okay, so because this is multiplication in the top, I can go ahead and do that and just do that for the y's. So I'm going to keep the x by itself times, I have y to the 2/3, and I'm going to subtract the exponent of 1. 2/3 minus 1 is going to give me negative 1/3. So I have x to the 1/2 power times y to the negative 1/3 power. So finally, if I want to convert this to have positive exponents, I can have x to the 1/2 over y to the 1/3 power. That could also be expressed as the square root of x over the cube root of y. That one probably looks a little bit better to you guys, and I would not disagree, but x to the 1/2 and y to the 1/3 are the same thing. Okay, this one looks like a doozy, but if you take it step by step, it's not too bad. The first thing I would do, you got a couple options here. I think I'm going to simplify these first. So the x's, I think I will simplify by getting them all together, but I'm not going to do the same thing with the y's, I don't think. Might as well let us be consistent. Let's do the same thing with the y's and then move on. So what we're going to do is we're going to tackle inside the parentheses first and then raise everything to the negative 2 over 3 power. Okay, so with the simplifying the x's, I have x to the 4, and I'm going to subtract exponents, so minus a negative 2. okay, because they're like bases. And then I have times y to the negative 6, and then I'm subtracting a 1/3. 1 over 3. Okay, don't forget that eventually we're going to have to raise this all to the negative 2 over 3 power. Okay. So now the first thing I'm going to do is I'm going to simplify this x. So 4 minus a negative 2 is x to the 6. And then I have y to the negative 6 minus 1/3. Well, I need to get a like base. Basically, this becomes a common denominator problem. So negative 6 minus 1/3. Okay, I need to make this so it's negative 18 over 3. That's the same value as negative 6. It's equivalent fraction now. Minus 1/3. That gives me negative 19 over 3. Okay, so now my y is times negative 19 over 3. Okay, and I'm raising all this to the negative 2/3 power. Now, I could make this positive and put it all over 1 and then go from there. But because I have some negative exponents inside and on the outside, I'm going to go ahead and kind of distribute this exponent to both terms inside first and then go from there. Because I might save myself some work that way. So I have x to the 6th power times 2 over 3. I get, let's see, that's negative 12 over 3. That's going to give me negative 4 times. Then I have negative, what is that, 18? No, it's positive because it's negative times negative is positive. So I have 38 over 9. There's nothing that cancels there, so positive 38 over 9. I need to move this x to the bottom. So I have y to the 38 over 9 over x to the 4th. And I could change it into radical form in the top if I wanted to. It's really not necessary, but just to show you what that'd look like, it'd be the 9th root of y raised to the 38 power over x to the 4th. Raised to the 38 powers is ridiculously big, so that's going to be an interesting answer there. Okay, now because I have fractions, this problem is a lot easier when you convert this into rational exponents first. So I'm going to change this to x to 3 needs to be in the top because we're raising it to 3rd power, and then we're taking the square root, so that needs to be a 2. Over, here we have the opposite. We're squaring it first, and then we're taking the cube root, so that's a 3. Now, if I have a division of exponents with like bases, which I do here, I need to just subtract the exponents. So I have x to the 3 over 2 minus, let me use that in blue because that's what the key above says, 2 over 3. I need to have a like base. So this is like a common denominator problem. I multiply it by something, and then I subtract 2 over 3, but I need to multiply it by something to get it to have a common denominator. In this case, I'm going to multiply this one by 3. My common denominator is going to be 6. I may multiply this one 2 over 2. So I get 9 over 6 minus 4 over 6, and that gives me 5 over 6. So this is going to be x to the 5/6 power, or the 6th root of x all raised to the 5th power. And that is another way to do this problem. But to me, that looks the best. From this to that is a big upgrade. Okay, now we have this monstrosity, what appears to be a monstrosity, going on. So we have z, and the first thing that's happening is it's raised to the 4th power, but then it's also being raised to the 1/2 power. That's what that square root means on the outside. And let me break that down one more time. So we have z to the 1/4 power. That's the same thing as the 4th root, yes? And then that is being square rooted. So I change that square root into an exponent of 1/2, and that makes it a little bit easier to see. So now that's just z to the 1/8 power, or the 8th root of z. And there you have it. That's a great summation of rational exponents. Hope you found this helpful. See you next time, everyone.